Oh, so this is our time versus speed graph that we created in the previous video. I have taken this directly from the packet though, so the dots should be a little closer to their actual locations, although this was still created by me dragging dots onto this grid. So it simulates more along the lines what you would be doing by hand plotting. I did not use graphical analysis software such as Google Sheets or Excel to create my graph. So there's still going to be some error in these points, which is okay because every time we hand graph, there's going to be error. There's no way for us to get this exactly correct by hand. So I'm going to draw a best fit line. And to do that, since I don't have a ruler, I'm just going to draw a line and we're going to kind of drag it around and see what we can do. So if I was drawn this line, this probably is not a really good line. It's close, but if I kind of look, I've got 1 point dead on here, and then this point's a little below, and then I have 3 points on the end that are very far above. So even though it kind of goes through my data, it does kind of represent the trend, but I'm not as close as I can get. So if I were to grab this thing and drag it a little more, I do kind of want to make this match what is in the packet. So in the packet, I have something kind of, let's see, where are we at? I'm gonna do something kind of more along the lines of this. So need to come higher. I think I came a little lower here. I think it works pretty good. I'm a little far above and a little far below kind of here, but this is going to be really, really, really close. Close enough, I think. No, maybe not. So that's what I do with my ruler is I kind of shift it around and I see what I'm really looking for is I'm looking to get my points as close to the line as possible. So I can see that none of my points here are very far away from the line. So like this one's not very far, that one's not very far. These two, that one's dead on the line. That one's kind of really close and that one's really close. So this would probably work. There's a little leeway that I could have in my lines and still make this work. Like I said, my original line was a little different. I could go a little shallower. I could go a little steeper. Everybody's line is going to be a little different. So when you do check the answer key for like graphical analysis problems or you're working a lab, one of the most annoying things is you're not going to get the exact same thing that your classmates have. But you have to make sure that what you do makes sense for the graph that you drew. So once we have a graph, we need then to choose 2 points that are going to be on our line. Now, if I look, I don't quite have the points that I did before, so I'm going to do another little shift just to get the ones so that they match the packet. So if I do that, I'm going to grab this guy and I need to get the points 25 and see 11. So I need to move this up just a little bit to get 25, 11. And I need to make sure that I have 70 and 6. That's close enough to 70 and 6 right there. So that'll work. So why did I pick those points? So if I'm looking at my line, I'm looking for 2 points that are going to be on the line that go through a grid intersection. So this point right here, that is a grid intersection for my line. If I go and look, the other point was selected was this one right here on the packet. Actually, the way this is drawn here, I would say that point right there is actually a little closer, but that's not the one that's in the packet, and I want to do this to match the packet. So when I do that to match the packet, it's these 2 points right here. So the one on the left is point 1. So then I read the coordinates. So this coordinate here, when I go through and look, is 25. So that's going to be 25. I'm going to keep the unit with it, kilometers per hour. That's not something you're used to in math, but it's really important to keep units with our numbers in physics. and then we are going to have 11 hours. So 25 kilometers per hour and then 11 hours. That's going to be my first point. My second point down here, I'm going to use this point. On the x-axis, that is at 70 kilometers. So point 2 is going to be 70 kilometers per hour. And point 1 is going to be at 6 hours. So I have my best fit line. I've chosen 2 plots. Please do not put a dot inside of your points. You might see that on people's websites and things, but the AP exam graders will read that as a data point. So do not do that. Leave open circles, and you have to circle your points. This is so important. They have to be able to track your work. They have to know why the numbers you did. You need to circle the 2 points that you use for your slope and your best fit line calculations. So then if I come down, I need to calculate slope. So when I calculate slope, there'll be a question on every AP exam that asks you to do that. And I'm going to write out the equation. Slope is equal to y2 minus y1 over x2 minus x1. I do that every time. You do that every time. It may sound annoying, it may sound like extra work, but you are defining your process, why you're doing what you're doing, so someone can track your work. And then I'm going to choose point 2 is x2 comma y2. This is x1 comma y1. So I need to plug in and show my numbers plugged in with the units. So y2 is 6 hours. So 6 hours in parentheses, and then I'm going to subtract y1, which is 11 hours. And then on the bottom, x2 is 70 kilometers per hour. Yes, you need to keep your units with your numbers, minus 25 kilometers per hour. So I show that plugged in, and then I plug into my calculator. And when I plug that into the calculator, I'm going to do this actually in my calculator now so I can look at my rounding and so forth. I think the calculator gives me, when I plug in, I'm going to do on top 6 minus 11. I'm going to divide by 70 minus 25. You do need to make sure that you're using parentheses properly or doing it in pieces, but don't round until the very end. It's better to do it all as one calculation. If you're doing it all as one calculation, the calculator, put your top in parentheses and your bottom in parentheses. So do your numerator and then divide by your denominator and use parentheses enclosing your whole numerator and parentheses enclosing your whole denominator. That'll make sure you get the right answer. And I suggest you plug it in the calculator with me so you can track what's going on. Now this gives negative 0.11111111111. So that doesn't make any sense. When you go back and look at the data table, which I don't have in here now, but my speed values all had 2 digits. And my times had 3 to 4 digits. So when I do significant figures, I want to round to the smallest number of digits that are in my data. So that is going to be 2. So what I'm going to do is I'm going to go and keep 1. The 0 is not significant, and I'm going to use the 1 here. I'm going to use the number after that. So I want 2 significant figures. So I'm going to use the 1 here to round the 1 so it stays a 1. So my slope is going to be negative 0.11. And then my unit is going to be whatever's on top, which is hours, divided by whatever is in the denominator, which is kilometers per hour. So that is going to be hours divided by kilometers per hour. Now, this unit does actually simplify. I don't believe I simplified it in my work, but eventually you might want to do this because that's really annoying to write. If I did want to try that, I would have hours divided by kilometers per hour. Now, when you have fractions on top of fractions and so forth, what I can do is I can change this one on top into hours over 1 over kilometers per hour. And then I can flip and multiply. So I basically multiply the top and bottom by hours over kilometers. hours over kilometers, because hours over kilometers divided by hours over kilometers just cancels. So that is not actually changing my value. And then what happens is hours and hours cancel, kilometers and kilometers cancel. I get hours times hours over kilometers. So this hours over kilometers per hour is actually the same thing as hours squared per kilometer. Now, I don't really know how much simpler that is. It is a little simpler because I don't have division and division, but I've got that square in there, which is why I didn't go ahead and do that in the packet, at least not this time. So my slope here is going to be negative 0.11 hours per kilometer per hour. Make sure that you're checking the sign. This should come out negative because my slope is negative. Okay, it's going from higher to a lower number. So that is a negative slope. So that is my slope. Once we have a slope, we also need to find our y-intercept. Do not just read the y-intercept from the graph. My y-intercept would be this point right here. Don't read it from the graph. We have to calculate it. But being able to look at it and say, oh, okay, does my y-intercept make sense is a good thing to do to kind of check your work. So we use the equation y is equal to slope times x plus b. B is our y-intercept. So I want to get b by itself. And I show this every time. I start here every time and I show my algebra. So to get b by itself, it's being added to this term slope times x. So I'm going to subtract the slope times x. I know in math, you're used to writing out the word, you're not going to write out the word slope, you're just going to write m, y equals mx plus b, but m in physics often stands for mass, so we try not to do that. It can get very confusing. So I would just always be in the habit of writing out the word slope instead of m. So that way, when it does happen to have m in the equation, you're not going to get confused and you're not going to confuse anyone else. So the slope x cancels on the right. On the left, I get y minus slope times x, and that's equal to b. And then what I'll often do is I'll rewrite that from left to right so it makes more sense. So b is equal to y minus slope times x. And then I will show my numbers plugged in. Don't do any math in your head. So my y value, I'm going to choose one of the points. It looks like we used 0.1, so the 11 hours for y. Once again, show your units. Our slope was negative 0.11 hours per kilometer per hour. And then my value for x was 25 kilometers per hour. I kind of ran out of room here, so I'm going to write my kilometers per hour underneath, but make sure I've got that parenthesis there. So then what I'm going to do is I'm going to do my calculation. So I'm going to plug this in the calculator. I am going to get 11 minus a negative 0.11 times 25. And that gives me 13.75. But as we did up here, we used two significant figures because that's the approximate number of, that's the smaller number of significant figures we have in this problem. So I'm going to count from the left, 1, 2, and I'm using the number to the right to round up. So 13.75 becomes 14. And then my unit is going to be hours. Now I know it's going to be hours because it's a y-axis variable and hours is my unit on the y-axis. But actually this kilometers per hour is in the numerator. It's kind of hard to see here, but it's not in the denominator, and the kilometers per hour is in the denominator here. So the kilometers per hour and the kilometers per hour actually cancel, leaving you with hours minus hours, actually plus hours technically, because those actually add. So we get 14 hours. And if we go back up here to our graph, we can see that that y-intercept is really, really close to 14. It's not quite 14. It's a little bit less, but with significant figures, it comes out to about 14. So now I have a slope and I have a y-intercept. So I come back to my y equals slope times x plus b. So I plug in my value for slope. I open a parenthesis and I include my whole value for slope, which is the negative 0.11. And that was hours divided by kilometers per hour. And then I leave x. and then I plug in B, which is 14 hours. Notice that I put my number with its unit in parentheses. So that way my variables don't get confused with units. The units stay with the number inside the parentheses, the variables go outside. Now that would be all well and done. We're pretty close, except for this is physics and Y and X actually stand for something. In this case, if you look at the prompt of the problem, they told you that time is lowercase t and speed, we use a lowercase v. So we always want to switch from our x-axis variables to our y-axis variables, from x and y to those physics variables. So our y-axis was time, so I replace y with time. I keep the slope exactly as is. And then my x-axis variable was speed, v, and I keep my y-intercept as is. And so that is now our best fit equation. And with that best fit equation, we could come back up here and we could make predictions for data that we don't know. The slope sometimes has meaning. It tells us different things. In this case, this is not the most meaningful slope in terms of kind of what we might do with it in AP Physics. It was just a data set that I found. But for example, if I wanted to find how long it would take to go a different distance, for example, or a speed, sorry, there's no distance in this one, just speed. For example, if I wanted to figure out how long it would take me to do whatever this is, drive or something like that, if I was going a speed of 100 kilometers per hour, which is pretty fast, what I could do is I could plug in. So my t would be the negative 0.11 hours per kilometers per hour. My speed would be 100 kilometers per hour. And then would add 14 hours. And so I can see that my kilometers on the bottom cancels my kilometers per hour on the top. That doesn't have a denominator, leaving me with just hours. So I'm going to get negative 0.11 times 100. And I'm going to add the 14. And this tells me that my time would be 3 hours. So if I was to go over here onto my graph and I was to look at 100, now when am I at 3? Well, I'm not quite at 3 now. This is a slightly different line than I had before. 3 would have been here. But remember, we did some rounding in order to get here to our best fit line. And so 3 is a little high, but it's definitely not 2. But with significant figures, not having a decimal here, then what this gives me is basically a range of about 2 to 4 hours. So it's basically my value 3 hours plus or minus 1 hour for one. So that 3 could go up or down by 1 with our error in estimation. So that does give me a value. I could pick a value that's actually not on my graph, and I could predict, for example, I could find like what would happen if my speed got really, really fast. Well, I can see if my speed got really, really fast, I'd get really, really close to 0. So I can figure how fast would I have to go for it basically take no time. Technically, this data shouldn't be linear because it should always take me time if I'm going a distance. So this actually might be curved data, but we're just going through and assuming that to the best of our knowledge, it was supposed to be linear data. So that is how you draw best fit equations and use best fit equations to learn things about the world around us.